Welcome back students to my course, and this video is dedicated to the lecture 11 presentation of maps. So in this video we will learn some theoretical background concerning the map presentation making legends. Introduction. Maps in ArcMap are based on spatial data. Spatial data refer to information about the locations and geographic features on the Earth's surface and the relationships between them, along with attribute information describing what these features represent. We can communicate complex information more effectively using maps than tables or lists, because maps take advantage of our natural abilities to distinguish and interpret colors, patterns, and spatial relationships. When you display your data properly on a map, you will see spatial distributions, relationships, and trends that you couldn't see before. Your maps will help you to make decisions and solve problems. They also help to communicate your information and results more effectively to others. So using the symbology editor to symbolize your data. Symbolizing your data involves choosing appropriate colors and symbols to represent features. This also involves grouping or classifying features according to their attributes and attribute values. Symbolization is a powerful tool used to explore, understand, and analyze your data. So this is the symbology tab. You can find it in a layer properties of your dataset. You use the symbology tab in the layer properties window to control how dataset is drawn in the view window. When the symbology editor is opened, you can choose for each dataset a map type on basis of the type of information your map represents. ArcMap has various map types chosen from. So here on the left side you can see the map types. You can choose features, categories, quantiles, charts, and multiple attributes. So features more always are represent each symbol in a single color or single symbol. Categories are unique values which mostly referred is suited to discrete data or discrete raster data, or just attributes which have discrete values. And quantile are more suitable to continuous rasters, or vector which with the attributes which have the float values. So classification. So in categories or quantile types of maps, you can find the classification of your maps. In this type of classification, you should know differs from the remote sensing classification. This type of classification is only distinguish divides your set of values into several classes, and we will discuss each of type of classification here in symbology tab. This first, when you open the classification toolbar button, you can see that you can choose the classification method here, as one of classification methods is natural breaks. Also, you can see the classification statistics, statistical values, mean, sum, medium, etc. Also, you can see the break values of each class on the right side, and here is a histogram how is your data in general is distributed. So let's now see what type of classification methods exist in symbology. So the first one is manual, then equal interval, defined interval, quantile, natural breaks, geometrical interval, and standard deviation. So manual classification. If you want to define your own classes, you can manually add class breaks and set class ranges that are appropriate for your data. Alternatively, you can start with one of the standard classification and make adjustments as needed. So you can see on the right side the manual classification. You will change the class values. You can set the class values here. And when you choose manual, the number of classes already distinguished. So manual type of classification, you can just set values in the break values field. So our next type is equal interval. Equal interval divides the range of attribute values into equal sized subranges. This allows you to specify the number of intervals, and ArcGIS will automatically determine the class breaks based on the value range. So here as an example you can see the map of percent population under 5, and equal interval defined as divides the classes into and divides the number of values and gives it to each class, which has the same range. For instance, here you can see from 3% to 6% the first class, the second class from 6% to 9%, etc. One of the disadvantages of the equal interval, you can find it here on the histogram, right? For instance, you set the equal interval on the classification method and set the number of classes into 6, but you can see here on the histogram that your data is not equally distributed. So most of the data you can see is within the first class here, right? The first class, while the other classes mostly do not have the numbers, the objects, geometric objects within them. So this is one of the disadvantages of the equal interval classification method. The next one is defined interval. Defined interval allows you to specify an interval size used to define a series of classes with the same value range. For example, each interval will span 75 units. ArcMap will determine the number of class breaks on the interval size and the range of all field values. In the example below, the interval size is specified as 4%. So the difference between the defined interval and equal interval that you can just put the interval size manually, while equal interval ArcGIS automatically divides classes in from the lowest point to the highest point and divide it into equal intervals according to the class number. So to set up the defined interval classification, set the classification method to defined interval and specifies the interval size. So here is the defined interval, and the number of classes here is 7, and the interval size is 400. So we divide it into 7 classes, and it changes the number of classes automatically when you define the interval size. So here you just put the interval size. Here see that the first class is 400, the second is minimum is 800, and so difference is 400. So quantile. Each class contains an equal number of features. A quantile classification is well suited to linearly distributed data. Quantile assigns the same number of data values to each class. There are no empty classes or classes with too few or too many values. So the quantile classification do not look to the class range. So for instance, if here the first class is from 2.7 to 6.3, so range is 3.6, right, percent, while the second class is from 6.3 to 6. And only 0.5 range, right? But the number of values, the number of data values within each class is the same. So here you can see that your histogram of your data values is like here, and within each class, for instance this class or this class, so the class range is significantly differs. The number of values here is the same, right? Here, etc. And this class range is very small, but it contains the same number of data values as other classes. So this is one of the advantages of the quantile classification. The next one is natural breaks, which is mostly used by GIS professionals. It is more comprehensive type of classification, a symbology tab, and if you want to know more, I will suggest you to make research in the internet. So natural breaks classes are based on natural groupings inherent in the data. Class breaks are identified that best group similar values and that maximize the differences between classes. The features are divided into classes whose boundaries are set where there are relatively big difference in the data values. So when you choose natural breaks and the number of classes, the ArcGIS automatically differentiate between the data values and put each data value, for instance, in our case, the attribute percent population under 5, into from each polygon into different classes according to looking to the differences between classes, maximizing the differences between classes. The next type is geometric interval. So the geometric interval classification scheme creates class breaks based on class intervals that have a geometrical series. The geometric coefficient in this classifier can change once to its inverse to optimize the class ranges. The algorithm creates geometric intervals by minimizing the sum of squares of the number of elements in each class. This ensures that each class range has approximately the same number of values with each class and that the change between intervals is fairly consistent. So here we can see an example. So the geometrical interval. So we can see the class range is differs. Here 3%, 1%, 1%, 2%, and 8%. So geometric interval is close to the quantile classification method. It tries to fairly distribute the data values within each class. This algorithm was specifically designed to accommodate continuous data. It is a compromise method between equal interval natural breaks and quantile. It creates a balance between highlighting changes in the middle values and the extreme values, thereby producing a result that is visually appealing and cartographically comprehensive. So this is also very comprehensive and complicated type of classification. I just suggest you to, if you're familiar with the statistics also, I suggest you to make more deep research in the internet. So, and the last type of classification is the standard deviation. The standard deviation classification method shows you how much a feature's attribute value vary from the mean. ArcMap calculates the mean and standard deviation. So here is the population under 5 deviation from the mean, and each polygon has its own population. And when you see, open the histogram, right? Histogram, if it's for instance normal histogram like this, and here is the mean, right? And this is the one standard deviation from the mean, and this can be the second two standard deviation from the mean, etc. This is the minimum number of population, and this is the maximum number of population, right? And ArcGIS calculates the population sizes from each polygon. For instance, this yellow colored polygons, right, have the closest to the mean number of population, while this red colors have the much smaller number of population compared to the mean, and the blue color polygons have the population which is much higher than the mean population. So why it can when it can help us when we try to differentiate between the classes, when we try to see when, for instance, when we try to statistically understand the data distribution and to search polygons or just geometric objects which has the bigger discrepancies from the average number of values.